An axis is the straight line that things rotate around. When an object turns about an internal axis, that is, an axis located within the body of the object, the motion is called rotation, or spin. When an object turns about an external axis, the motion is called revolution. The Ferris wheel turns about an axis. The Ferris wheel rotates while the riders revolve around its axis. Earth undergoes both types of rotational motion. It revolves around the Sun once every 365 days. It rotates around an axis passing through its geographical poles once every 24 hours. The turntable rotates around its axis, while a ladybug sitting at its edge revolves around the same axis. Which part of the turntable moves faster? The outer part where the ladybug sits, or a part near the center? It depends on whether you're talking about linear speed or rotational speed. Linear speed is the distance traveled per unit of time. A point on the outer edge of the turntable travels a greater distance in one rotation than a point near the center. The linear speed is greater on the outer edge of a rotating object than it is closer to the axis. The speed of something moving along a circular path can be called tangential speed because the direction of motion is always tangent to the circle. Rotational speed, sometimes called angular speed, is the number of rotations per unit of time. All parts of the turntable rotate about the axis in the same amount of time. All parts have the same rate of rotation, or the same number of rotations per unit of time. It's common to express rotational speed in the unit revolutions per minute, or RPM. Tangential speed and rotational speed are related. Tangential speed is directly proportional to the rotational speed and the radial distance from the axis of rotation. In symbol form, V equals R omega, where V is the tangential speed and omega is the rotational speed. You move faster if omega increases. You also move faster if R increases. At the axis of the rotating platform, you have no tangential speed, but you do have rotational speed. You rotate in place. As you move away from the center, your tangential speed increases while your rotational speed stays the same. Move out twice as far from the center, and you have twice the tangential speed. Velocity involves both speed and direction. When an object moves in a circle, even at constant speed, the object still undergoes acceleration because its direction is changing. This change in direction has to be caused by a net force, otherwise the object would continue to go in a straight line. Any object moving in a circle undergoes an acceleration that's directed towards the center of the circle, a centripetal acceleration. Centripetal means toward the center. The force directed towards a fixed center that causes an object to follow a circular path is called centripetal force. If you whirl a tin can on the end of a string, you have to keep pulling on the string, exerting a centripetal force. The string keeps the can moving in a circular path. The force exerted on a whirling can is toward the center. No outward force acts on the can. Centripetal forces can be exerted in a variety of ways. The centripetal force that holds the moon in its almost circular path is gravity. Electrical forces provide the centripetal force acting between an orbiting electron and the atomic nucleus in an atom. Anything that moves in a circular path is acted upon by a centripetal force. Centripetal force is not a basic force of nature. It's just the name we give to any force that causes circular motion. Centripetal force holds a car in a curved path. For the car to go around a curve, there must be sufficient friction to provide the required centripetal force. If the force of friction isn't big enough, skidding occurs. The clothes in a washing machine are forced into a circular path, but the water isn't, and it flies off tangentially. Greater speed and greater mass require greater centripetal force. Traveling in a circular path with a smaller radius of curvature requires a greater centripetal force. Centripetal force is measured in newtons when m is expressed in kilograms, v in meters per second, and r in meters. Sometimes an outward force is also attributed to circular motion. This apparent outward force on a rotating or revolving body is called centrifugal force. Centrifugal means away from the center. When the string breaks, the whirling can moves in a straight line tangent to, not outward from the center of its circular path. In the case of the whirling can, it's a common misconception to state that a centrifugal force pulls outward on the can. In fact, when the string breaks, the can goes off in a tangential straight line path because no force acts on it. So when you swing a tin can in a circular path, there's no force pulling the can outward. Only the force from the string acts on the can to pull the can inward. The outward force is on the string, not on the can. It's the reaction to the string pulling on the can. The only force that's exerted on the whirling can, neglecting gravity, is directed toward the center of circular motion. This is a centripetal force. In this picture, the can provides the centripetal force necessary to hold the ladybug in a circular path. The can presses against the bug's feet and provides a centripetal force that holds it in a circular path. The ladybug in turn presses against the floor of the can. Neglecting gravity, the only force exerted on the ladybug is the force of the can on its feet. From our outside stationary frame of reference, we see there is no centrifugal force exerted on the ladybug.